Right, so good morning from Sunday, the December of 7th of December. Here I am starting a bit early today with the advent of code question. Just to summarize who am I is I'm a software engineer with 3 years of experience. I'm living in Munich, working for a financial company. I work mostly as a backend throughout my career, so here I am practicing these kind of questions daily, and I open streams just for the joy of it, for the fun of it. I like creating content in general, and I go through the advent of code questions, which are programming puzzles, let's say. Yesterday we went over the last one. The fourth one, not the last one, but I will continue with the second part of the question. But let's start with the refactoring of the old one because I didn't really like it that much. So let's ensure that the value is 1457. And let's go. So we don't have to write it to a txt. Apparently I was wrong. The whole logic is basically this is the reading part, reading the grid and returning a 2D grid, right? That's, I think, very easy to see. We have this input we call read grid here. We have the grid size. We have the output grid. We basically deep copy. And then we have this easy accessible method, but if I were to skip that, look, the accessible count. So the forklift is trying to get these papers, and accessible basically mean left. And you basically have this counter here, right? And then you're just increasing them and returning it in the end. For the input grid was a square, so we're going over this each row and column here. Here we have the position basically. And then we check, okay, if in this position, if there's a paper roll and if it is accessible by a forklift, we're going to put X there and increase it. Probably we also don't need to deep copy the output grid as well. Just that I noticed right now, as we are only interested in the accessible count, right? So let's get rid of this one as well. And I think this command is also not necessary. And this output, yeah, we don't need this, and as a result we don't need this one as well. Okay, if we were to go through this is accessible method, we basically check all 8 dimensions. These are the neighbor deltas, right? Deltas, you can say, like it's look to the left and down, so the lower left neighbor. This means the row actually, so it means look to the down neighbor and that kind of stuff. So you have neighbor deltas, and you're checking then if neighbors has paper, and you're just counting them. For delta and neighbor deltas, you first check if we are out of bounds. If we're out of bounds, all right, there's no neighbor there, so there's no paper there as well. You can just continue. And also you do the same for this one as well, for the column. So you're checking the left and right here. here you're checking the up and down. As a result, if you're inbound and you have a paper roll there, you're increasing the count. And if the paper count is less than 4, we return true. It's accessible by the forklift. I think this should result the same value. Okay, I think I'm happy with this version. Let's go to the part 2. Oh, oh, all right, interesting. So in here, you're checking, okay, this can be removed, this can be removed. Okay, you've removed them, for example, here. And then this one was not be able to remove, but now it has less than 8, so 4, sorry. So it can be removed actually, right? So each iteration, the input grid is changing, right? And then you stop once no more rolls of paper are accessible by the forklift, right? Yeah. So the grid is changing, and with every change, you'll just go over it again and again, I think. I'm wondering if I can actually replace them in place. Meaning, if I were to go through here and I see, okay, it has less than 4. If I do an in place change, like if I change it directly to X, what would happen? And then this one to X as well, and then this one to X. This one will also be X, and this one, the result will also be X. This one will stay, so yeah, it will also be X. So we'll go, and this one will be X, this one will be no, this one will be no, this one will be X, this one will be X, this is X, this is X, this is X, this is X. So I think like is a result, and you'll go through. You'll eventually reach to the point that you'd like to achieve. It will be a bit different than the logic here, but eventually it should arrive to the same state. I'll put X, but I think that's okay, just to represent like what we've done there. Sorry, it's a mess here. Let's have a new file here. Is it? Yeah. Is it? Let's put it here. It is actually part 2. Let's copy this bad boy here, and now we are going to have this logic. Yeah, basically we can have this like get we can call it like this. We will call it with we'll always call it with the input grid, but maybe we don't need to pass it. But here it will return us the accessible count. Return accessible count, and we are just going to do this thing. So it is the same value. So we just we have this input grid size, and then this one has already an access to it, so it's okay. But the thing that we'll do here is we'll just modify get accessible paper rolls count. We'll also modify it. I like to call something like this. And here, if it's accessible, we decided to put an X there. And we'll just say, okay, while true, let's have this one call, right? Yeah, we can basically call like if there is something here, right? If it's not 0, basically, we can continue. But if not, if there's nothing there, if not 0, basically, it will enter here and we'll just break. Okay, I just noticed that we also need to, we are getting this count right. So maybe total paper rolls count, and we can currently accessible, right? Accessible paper rolls count. Oh, it's a bit. And we check like if there's nothing there, just return the total accessible paper rolls count. Else, sorry, it's print. Or maybe you can just break it here, right? Else you'll just append this value to here, right? It can also come like this. If it's 0, it's okay. And in the end, you'll just print the total accessible paper rolls count. Alright, we have a lot more. I'm wondering if I can test this thing on input test txt, so that, yeah, we see 43, right? And in here it also says 43, so I think it's okay. This result we found should be the correct one. That's the right answer. Okay, perfect. Let's move on to day 5 if you like. Inventory management system has bugs. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. Okay? The fresh ID ranges are inclusive. The range 45 means the ingredient IDs 455 are fresh. The ranges can also overlap. An ingredient ID is fresh if it is in any range. Yeah? Yeah. That's okay. The L's are trying to determine which of the available ingredient IDs are fresh. In this example, this is done as follows. Okay, let's go through. I think it's already here. Ingredient ID 1 is spoiled because it does not fall into any range here, right? Ingredient ID 5 is fresh because it falls down to here. Ingredient ID 8 is spoiled because it does not fall into range. 11, it is fresh. It is inside here. 17 is fresh because it's here. 32 is not fresh. So in this example, 3 of the available ingredients are fresh. Process the database file from the new inventory management system. How many of the available ingredient IDs are fresh? All right. I'm just not sure how to solve it at the moment though. So we have this ugly, so this is 0, and we have between 3 and 5, we have something here. Let's say, what happened? We have here, we have, this is 3, this is 5, we have 10, 14, 16, 20, and 12, 18. Oh, it is ugly. Ugh. Okay, so this is one thing. 10 to 14, one thing. 16 to 20, one thing. And of course 3 to 5, as I've already said. So 1 is here, it's spoiled. 5 is here, it's okay. 8 is here, it's spoiled. 11 is here, it's fine. 17 is fine. 32 is here, it's not fine. Okay, so this is how, as a human, I solve. What would the computer think? In the brute force way, probably I can check, okay, this 1 is here, I have the inputs here, I can sort these ranges, and they are sorted right now. Not sorted, but this 12 will go up, right? I can say, okay, let's sort them by the first number here, and then I'll check if 1 is bigger than the first one. Okay, it's not. Okay, then it's a spoiled one. But for 5, yeah, it's bigger than this. and I will check, okay, is it, yeah, does it, is it in the range of this one? Yes, okay, then it's a fresh one. For 8, you will check, okay, it's 3, is it in this space? No, let's go. 8 is bigger than 10? No, okay, then it's not fresh. For 11, it will come here and it will be fine. For 17, it will come here, it's not in this area. For here, it's in this area, right? And it will be fine. And here. Um, that's one solution. I don't know if this makes sense to you right now. That's a working one. I don't want to overcomplicate it at the moment. We can, along the way, we can always extend the complexity. Not, yeah, it will be more complex probably, but like we can always optimize it later on if I can write it in a readable fashion. That's a challenge. Okay, so let's go ahead. As always, we'll have input txt, and we always have the part1 pi. The input txt, perhaps we can also put this one as there here. Not here. Input text. Now perhaps we can also move from this one as well. But yeah, so the input txt is comes here. All right, they're like very big numbers, right? Let me close these things. Okay, and yeah, we're good. So I don't know. First, we need to read the file, right? We need the file. We need to have the fresh ingredient ranges, which can be a tuple, right? And then we will have the available ingredients, right? We have like basically available ones, available ingredients, get fresh ingredient ranges. They're all going to come through this read input, I would say, and it can it will have the path as a string, and it will return us this information. So I would prioritize the ordering in this input text. So we'll have the ranges first. So ranges will be a list of tuples, and they will be integers both sides, right? And the other part will be so basically we also have a tuple here. So the first part is the ranges, and the other part is the ingredients. They are just list of integers. Cool. Let's pass it for now. All right. And we'll have the fresh ranges, I would call, I think, and availables. Read input, and our input could be Q5 input test, and yeah, I think we can just start as always from end to end, right? Let's go ahead and implement this one. Open, we'll open the file as a read mode. As always, we can enforce an encoding. I think new line, what this new line does, I'm not sure. I just, yeah, this, I think we can try that. Um, yeah, mode is one, da 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 da, new line. What do you set in new line? I just want to read this in a proper way. I don't want to, I was doing this. I was doing this kind of thing. It's ugly. Like there should be. I don't want to strip it. Like this part, okay, it's okay, but I don't want to read line and strip it. I will just ask this one to do it. Let's have no eligible models available. I don't know. Anyways, just read the file, please. Okay, it does that actually. Um, I don't want. Yeah, so yeah, it's reading for line and file and it's stripping it. Okay, I don't want the other things. We have the path, and that's it as f, right? And we can have line strip. Okay, so I would like to. So I will read the line and variables. Okay. If line is empty, it is possibly and availables. There's no availables that we didn't process them, right? It means, yeah, we'll go on to the next one. By the way, this will be a true. Maybe we can say like if not line and there's something there, we can just break. We're just read the demo. If oops, what's going on? If not line and there is no availables as well, we didn't process them. Okay, then we'll just continue to the next one. Or maybe you can say like ranges completed or that kind of boolean. I don't know. Yeah, ranges completed true. if line, so if there's a line there and not range is completed, you basically you'll split it with, in terms of this, you'll have two values there, and then you can make them a tuple, and then you can put it to fresh ranges, append, like this. So if there's a line and range is completed, you will put them to availables, just as it is. You can, if you like, you can make them integers. I think it's always a good idea to cast them to integers. So you split it, that thing there, and you can I think we can do like a list comprehension, but for tuple. Not sure. So this will be the for value in, or like for ID, or yeah, ingredient ID. Yeah, we can also call that for value, right? For value in this range, we'll choose to typecast it to an integer. And can you just get rid of this thing, please? No, it doesn't. I don't understand why. Like, cursor, what do you do? Disable type hint. Yeah, I don't know. I think it looks good. Very important. Cannot impact non-iterable non-type object. Oh, we have none here. As we don't return anything. Surprise, surprise. Fresh ranges, availables. Let's go. Okay. 3, 5, 10, 14, 16, 20. Da da da. Da 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 da. Right? 4 ranges and 6 availables. Okay. So first part is completed. Alright, let's abstract this thing away. Perhaps we can remove it like this. It's perfect. So from now on, we can go into the next step. We can go through the available ingredients. We can have a counter, and for each available ingredient, we'll check if it's in the ranges, right? There is something that I'd like to do is I'd like to sort this fresh ranges when in terms of the first point, in terms of their starts. It will make sense in. So I think it will take the first key there. I'm not sure. We can see it. I think it does it in place. So yeah, as you can see, it does this sorting in terms of the first key, and yeah. All right, so we have these we have sorted the fresh ranges in terms of the first key, and then from now on we'll check for a ingredient in availables, and we'll check. We'll also have a total counter, right? Fresh counter. If is fresh ingredient and fresh ranges. If it's fresh, all good. We'll just increase the fresh counter. Sorry, I got frozen for a bit. And if it's not, nothing to do. And then we'll print the fresh counter at the end. And that's what we want to see. Let's implement this thing. It will have a ingredient, it will be an integer, and it will have a fresh ranges. It will be a tuple of integers. Not really, it will be a list of tuple of integers. It is in a sorted fashion, and will return as always true for now for the testing of it. What do we want to see? We want to identify all these things as fresh. So we expect to see 6. All right, so this part seems to be completed right now. This is what I want to see. So right now we'll focus on this part. We're going from abstraction to abstraction, and here is the part that we'll think about. By the way, I forgot to type hint the return type here, right? Or yeah, it should be a boolean. No, that's it. Okay, so given that we have fresh ranges and ingredients, I think like my initial idea is go through each range, basically find yeah, it will be a bit. So basically you can do a binary search there in terms of the fresh ranges. You can just search the so it will be then it will be log n, but I would like to encapsulate it. Like basically it's a search algorithm. There will be a search algorithm, and it will have the ingredient, and it will have this whole thing, and search first possible range index. Yeah, for this one it will return none. This one it will return 0. This one it will return something else, and something else. But basically it will return us an index, and we'll check. Basically we'll go through the list of ranges from there. Well, or maybe you can actually make it like a identified index, you can call it, but like for index in range identified index to, of course, this can be, if not identified index, you should return false. It's not fresh, okay? But if it's there, you would like to start from there, from that range to the basically to the end. Then fresh ranges, okay, and you'll have the range at your hand. Range start, range end, fresh ranges, index, and you'll check if range start is bigger than your ingredient, right? Then we have no way, it's like false thing, okay? If it is else, okay, we are inside the range, but we also need to check if range and is what case. So if range n is smaller than r the ingredient, we have to continue to the next index, because in the next range it can be possible we can find this ingredient in its range, but if it's not both of the case, so it's within the range, then I think we're going to return true. That's it. And in the end, you've already returned true actually. But if I don't know, if in the end this index, this didn't even enter or something like this happened, it means you haven't found it. So you just need to return false. Yeah. Let's write this thing. Let's say it always returns 0, right? I think this way, it will be the non-optimal solution, and I think it will work. Not sure. It didn't. Oh, okay. I have to check this one, right? It's none. No. So here it found it available at 3 of them, right? So if you always identify the first possible range index as 0, you're basically going to try each range, for it will have like an n complexity. Okay, so if I were to have a 100% confidence about writing the search algorithm here, I would have done that, but I don't feel like that at this moment. But I will try to do that. All right, but I want to try this thing. I think this algorithm so far should be correct, and I would like to try this one. Loading. Okay, that's the right answer. So that's good. In our first try, you've done it. Good. Let's write this thing back. So basically, you want to find the index in not in ON, but with ON search. Okay. But now we like to search this thing. Search the first possible index. Basically, search the first um, index that this value that we have in our hand, this ingredient, is higher than the first value in the range. Mm-hmm. I think here you check like you have the left pointers and right pointers here. And left pointer is, of course, 0. Right pointer is, let's say, what's ranges, fresh ranges? -1. And mid is left plus right, and an integer division here. And what do? You check while left is smaller than the right. Perhaps you do this calculation here, and you say if fresh ranges at mid and the first point is basically what we want to check is ingredient, right? Ingredient is smaller than this way, right? Then we should set up the right as mid, -1. If it is higher than it, then we have to update left to this part. If they're the same, then we're fine. We just found it. We'll just return the mid, the index, right? Okay, and if you can't find anything there, you'll just return none because you didn't found anything. Okay, this is the range. Let's so this is the range, and the value that we're looking for, let's say what, like these, right? Let's put them. So here for 1 we'll check it will go enter into this, and left and right. Left value is 0, right value is 3, and 0 plus 3 integer division 2, it's like 1. So this is the midpoint right now. We check if the ingredient, which is 1, is less than this this value. Yes. Okay, then right will be mid minus 1, which is this one, right? 0, 0. So we are at this point right now. But it should, I think, check this one as well, right? And here it will enter. Left and right are both 0. Integer division, it's 0 again. You check if the ingredient, which is 1, is less than this one. Yes. Okay, right will be minus 1. And left will be staying 0. And as a result, it will not enter here and it will return none. But if it were 5, we will still come here and it will check, okay, ingredient is smaller than this one. No. Okay. Sorry. Wait. 10. Yeah, it's smaller than 5 is smaller than 10. Okay. The mid is 0 right now. We're here. And fresh range is 0. This is free. If ingredient is smaller than a, no. Okay. If ingredient is higher than this, okay, yeah. So left equals to midpoint 1, which is 1. Right is already 0. But we will return none here as well. Okay, I think the only part that we like to handle return is the time when you exceed the limits of left and right. But if it's somewhere in between, you'll just return the midpoint, I think. Maybe you can check like if left is I don't know, less than 0, or right is less than 0, or left is equals to length of fresh ranges, or right is same length of fresh ranges. So if it's like outside of the range, we know that it's not in this list. But otherwise, the midpoint, I think you've already found it. So here in the midpoint will be this one. What about 8? It will come here again. It will also return this one. I guess so. Anyways, I think this should also work. Oh, it's not working. Okay, let's not give up. Let's think about it a bit more. It's definitely related to the search algorithm. I don't know. Let's try it. I don't know, with the input test, so that we can see our problem here. So yeah, it finds only the 1 here. Interesting. We can put some. You can put some. We can put the ingredient and identify the index. So for 1, it returns 0. Okay, for this one, yes, I expect 0 as well. For 8, we expect to have this thing. So it's 0 as well. For 11, we expect this thing. Okay, it returns 2, but not this one. I think it should have returned this one. Okay, let's go over the 11. I think this way we can understand. So the 11 case, we're looking at this one. Left and right. Midpoint is this one, and we check. We check. If the ingredient is smaller than this value, no. If it's higher than this value, yeah. Then we are going to check, we're going to move the left to here. Left will be staying here and right will be staying here. Hmm. I wonder if you can return left all the time. Maybe that's the way to go. Can I just quickly test it? No, it's not. It is not. Interesting. How come? Left is, yeah, 2 here. And the problem here is if you see the ingredient, oh my god. Yes, fundamentals. Hmm. 3, 10, 12, 16. Okay. And we have, so this, let's say this is the start and this is the end, the right pointer. And the midpoint here in this case is this one, this one. And for the input of 11, okay, that's the input that we are looking. So here the midpoint is here. We check, okay, if it's identical, no. If it's okay, it's this value is smaller than this value. Okay, I think that's an opportunity for us. Okay, this was the last, like this value, we can use it, we can choose it, right? We have to somehow remember that thing, it works, but we can always do better, right? So we just move this one to here, this one stays, mid will point to here as well right now, and we'll check, is it this value is bigger? If it's bigger, okay, we can go on, but it's smaller. So here we shouldn't choose this one. No. In this case, we should, I don't know, somehow remember that this worked. The last midpoint worked. Um, right. Okay, something is missing there. I think the result was 500 something, right? It's, I lost it already. But anyways, shouldn't I, maybe this was making it fine, I don't know. Here it's wrong though, yeah. Here it's fine. Let's, where's the other print? Here. It always return 0 actually. I think it makes sense. Instead of none, I would say. Like if you haven't find it there, but that's the problem there. Like if you have the res as like this, no, I think it shouldn't be a problem. I think it's okay. We can keep it like this. It's definitely okay. Yeah, I think this should work. But I don't remember. Was it this one? I don't think so. Let's see. Return res. I think this way we can see it's like, yeah, we are missing about 27. This is not working for a small number of ranges. It's somehow missing them probably. So it's, yeah, it's probably missing them. That's it. Because this way we're sure that it's going to handle it correctly. It will start from that direction and it will go on. if it sees a chance, it will continue to the very last thing. But here it's somehow, I think, this result thing, or like this mid thing is interesting. Interesting. Mm, hmm. I have an idea. If you have, hmm, can I sort this ranges first by the first value, then the second value? I think that will still, like, the issue is if you have this, so this assumes basically each element here is unique. Is each element here, the first elements are unique, but it's not the case. Like, you're returning mid, this one, I think this one is the problematic one. Maybe you can check, okay, this is high likely the result, you can call it, but let's check the, I don't know, like the left or right or whatever. Like, let's check the surroundings. We have to check it. How do you do that? Like, there might be many elements with this value here. We're searching here, but their end ranges could be different, which affects the freshness, right? Maybe you have to, yeah, you always have to choose the first value there. If you found it, okay, that's good. Probably that's the result. But we gotta look to the left of it, the first one. I think so. So it has to do something like this. Um, I'm missing something. Maybe right. It could be mid there. I don't know. No, I don't think it's the case. I don't see right now, unfortunately. Okay. Let's see. Let's have feedback. What am I missing here? It will probably give out a lot of response right now, but let's see. Do what you're gonna do, please. Let's use this one. Yeah, typo annotation is wrong. Okay. Interesting. Come on, man. You have to solve it right now so far. Okay, something's up. Okay. Mm-hmm. All right, I see the bug. I mean, yeah, that's okay. Wait, what's that problem? Your search index returns index 1. Is fresh then checks from index 1. Is it hmm, yeah. Oh, oh yeah. Oh no. Okay, what should I do there? Both the cases should go left. Okay, interesting. Like, I think this was a hopeful thing. This was the assumption was there wrong. I thought if I look to the right, I'll have bigger numbers there, but the bigger number can be on the left side as well. But I don't know. I really don't know how much complexer then it will be right now for this. I really don't know. Okay, it works. But what's the time complexity here? I think the time complexity will be okay, log n. Okay, that's okay. But um, here I'm iterating as well. I think the worst case is, yeah, I don't know. I think it's, yeah. Okay, so I really, I don't, R is number of ranges, I is the ingredients available. Search, this one does, oh, log R. Really? And this one, OR, first case. Uh, Yeah, it will do a war. So this will still, in that case, be the limitation. But let's go. I don't want to. I would just like to. Let's do it like this. I would like to keep it simple. This should be like it. This should go, and this should return the same result. Okay, good. So part 1 is over. We'll go with part 2 right now. Basically, yeah, let's continue to part 2. I'm coming in a minute. Coming in a minute as well. Oh, okay. I mean, like the simple example, the simple solution is, oops, wait. I mean, the simple solution is you can put everything into a set. You can traverse each range, put everything into a set, and return the set size, right? Let's go. Let's do that. Let's go step by step, as always, right? Um, okay. Forget about availables. Forget about is fresh. Read input can stay. Forget about sorting as well. Fresh set for. I hate it. Why do you? Okay. For start range start range end in fresh ranges. Fresh set add for ingredient in range start range end +1. Ingredienta print fresh set size. Oh my god. Oh my god. That's the reason. Oh my god. Look at it. It's still calculating it. Oh my god. get it. It's crazy. I think it's very intentional that they've done this very, very bit with very big numbers. Yeah, I think no, it's crazy though. But um, wait, what? You should have stopped right now. Okay. Wait, what? Can you please? Okay, finally. Still trying to stop, by the way. Let's try with the test input though. Oh my god, what's happening? Okay. Um. Okay. So yeah, I mean the algorithm works. The only problem is it's terribly slow. Right. We have to help the elves. Okay, let's go. Let's start interrupting it. Okay. All right. Mm. What's going on? What are we going to do? Yeah. So let's please let's do this and also print me the fresh um, um, fresh ranges. Okay. Is there a shortcut of it? Anyways, so 3, 5, 10, 14, 16, 20, and 12, 18, right? Let's go ahead. I may have an idea, but I don't know how to implement it, to be honest. My idea is the following. Can you please, like, okay, double click. So here, here is our input, right? So let me do this thing again. So here, we have three. Can we? What, can we do something like this? So we have 3, 5, 5, 10, 14. Maybe, yeah. Let's go back. Let's say 20, 12, 14, 16, 18, 20, 3, 5, 10, 12, 14, 16, 18, 20. All right. Let's show the let's put both ways and let's show them the green. So this is one way, one of them. It was 5. And 10, 14, another one. 16, 20, another one. And 12, 18, another one. So what I want to do right now is the following. I would like to have, instead of these 4 ranges, I would like to have less ranges, but I would like to show you, like, so this one will stay as it is, okay? But I would like to reduce the size of these ranges by combining them. So this has connection with this one and this one has connection to this one. As a whole, I would like to represent them as this. What does that mean? So if I have this, and imagine like we have this very big ranges, right? In that case, I don't have to iterate over all elements here, but I can directly check, okay, between 20 and 10, there are, like, if you put these things, like both inclusive, it's like 11 numbers here. So it's like the determining of this values, like, and you don't have to add them to a set as well. You can just say, okay, this one has 11, this one has 3, 4, 5, 3, so it's like 14, instead of having an additional storage. But the thing here is, you have to be like, we have to have some kind of good way of merging these intervals into themselves. I don't know, like, imagine you're a computer, you're looking at it, and 3, 5, okay, it's okay, and 10, 14, I don't know, like, we basically have some kind of maintaining a max one of this interval and the min one. Min one is expected to appear on the very left, right? So this 3, 5, you can say, okay, we have an interval, let's see, the end one is 5, and the next interval you can peek and you can say, oh, it's 10, okay, I think this is the first interval, let's put it into there, that's okay. And you can refresh, you can say, okay, this was interval, it ended, let's move on to the next one. So when you come to 10 to 14, you can say, you can possibly say, I noticed I moved a lot. Anyways, you can say it starts at 10, it ends in 14, okay. Let's peek into the other one. Is it, how is it? Is it 16? Oh, sorry. I got to put this line here because we've already sorted it. Okay, 14. Look at the right one. Oh, it's 12, so they're connected. Alright, that means I need to remember the minimum value and I need to check which one is the biggest. Oh, this one is the biggest. Right, and let's do, I mean, probably you can do something like this, which works. But another way of, like, you can remember, probably say, like, the min is 10 right now, the max is 18 right now, but we'll go on, because why are we going on? Because the next interval start is also smaller than, basically, if next interval start is less than the current max value, they're connected. Okay, so here in this case, 16 is less than that. Yeah, okay, then we have to check with 20. So 20, it could be our max. Okay, is it? Yeah, it's our max. Okay. Do we have a next thing on the right? Another element there? We don't have. It's the end of the journey. Okay, so then we have 10 to 20 we can add. So the resulting list should look like 3, 5, and it should be 10 to 20. Which is the case, right? And then you can translate, okay, this has size 3, this has size 11, which is 14. Okay, so let's have a look. So we won't have a set. We will sort this fresh ranges, and then um, we're going to merge these ranges. Okay, um, merge ranges. I will call, and we'll pass the thing. Um, you can call like merge ranges. You can call, and then for merged range in merged ranges, uh, you can total count, right? You can have a total, and you can say or yeah, merge ranges, range start, range end, and range end minus range start plus 1 total count. Increase that by what? By this value. And then in the end, return the total count. Not return, but like print. Good. So merge ranges. This is what we are going to do right now. Merge ranges. It will have this fresh ranges, and it will be a list of tuple integer. It will return another list of tuples. Expected in yeah, I mean, yeah, it's like this. Okay. So the first one, what do we do? We can return the fresh ranges directly, and we can calculate it. It's 20, it says, because this is 3, this is 5, 8, this is 7, 15, and this is 5, yeah, 20. Okay, so this part seems to be working fine. We can now focus on this one. As I said, we'll basically go through this each range while we can check like the current position, and while current is less than the length of the fresh ranges, right? Yeah, I think so. We'll iterate like this, and you'll have merge ranges, and it will be a list here. Yeah, perhaps you don't really need to store it in a way, but maybe, yeah, maybe we can optimize it. Like instead of having an additional storage here, you can probably calculate it already later on. Anyways, so for each one we have the current one, but we can also have current min and current max, right? We can set them up to none, I don't know, whatever. Or you can also do something like float inf, float, is it like minus inf or something like that? Or yeah, float inf, yeah, I don't know, we can handle it. So you'll have the, so here you'll get the fresh ranges, the current, so you have the merged range min, merge range max. I would like to call it like this, okay? And this is the current start, current end, and I would like to check that if the current end is smaller than merge range max. No, actually the reverse, like if it's higher than that, merge range max, we're going to update merge range max to the current end. Current start, no, it shouldn't, like this one should be the correct one, right? Merge range min, and that's also incorrect. I don't know, maybe you can actually set them to the first element here, and first ranges 1 1 sorry 0 1. Okay, so for the first element, cur start, cur end will mean merge range min, merge range max, right? If the current n is, so it will be identical here, but for the first element, but in the next element, so the yeah, yeah, I think this should be fine. What you gotta do, like you also need to check something here. So you updated the max, but you gotta check if the next one, if a cur is not equal to len fresh ranges, or like maybe it's done, right? You can check it out. You can check if cur equals to len fresh ranges -1, then basically we ended it. It's fine. But perhaps you can also do something like, if it's not that case, we can check something else here. If the fresh ranges cur +1, the next one has a start time that is smaller than our merged range max, it is connected to this one. Or even better, you can connect them like this as well, right? Yeah, I think so. Then you mean you can continue with what you want to do, okay? But otherwise you have to in all cases, I think you have to merge ranges, append this new thing, whatever you have, merge range min and merge range max. Okay, and then here in this case, you also do need to do that. It's not like if they're not connected at all, you have to append them, but you have to also do merge ranges. Basically, you have to merge range min should be the next one's start, right? And max should be the next one's. But I think you can also do it at the very start. You can perhaps you can make them none to none as a result. Maybe it's something like this. So this can be continue here. Else, do this. And at the very end, at the very start, you can check, okay, if merge range min is none and merge range max is none, just put cur start here, merge range max, put cur end here, and that's it. No, 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 not that. Oh, is it still slow? No, no, it's okay. Something. Oh, I'm not moving the current. Okay. the performance is fine right now. Yeah, it's very fine. Shall we try? That's the right answer. All right, so the implementation is very bad, but I think the um, this I think hopefully is clear to you if you've followed it. So basically, I'm merging the intervals and look at the time difference, right? Before it, I wasn't able to see the response. Now I'm able to see it because it's very, very fast. Because, yeah, like you don't really have to store these merge ranges here as well. You just need to um, merge ranges and calculate size. Okay, so merge ranges, um, size, you can call it, right? In here, size, you'll just add it. What's going to do is you're just going to have, let's append merge range max, merge range min plus 1. Um, that's it, and then you're going to return this thing, of course. This will be like an integer that you're going to return, and merge ranges, and call the totaling, merge ranges length, and that will be the merge ranges here. And the good thing about this thing is it doesn't use any extra memory. So you're just calculating the size along the way. And it's the identical result, as you can see. So that's good. The question 5 is over. So far we've done the half of the question 4, I believe, and now we've solved the 5th one as well. Now there is remaining 2 questions which I can focus in the afternoon. Maybe, I don't know, most likely. This is something that I don't understand, but yeah, I don't know. I don't know how it will end up. But yeah, then let's stop for now. It has been 2 hours apparently. And have a nice Sunday, folks.